Hello everyone. Look, this video is I am going to make this video for the demonstration purposes only. I am trying to make it smaller, as much smaller as possible. Okay. So today we will discuss about counting number of relations. Okay, counting number of relations. This topic is suitable for class 12 children and the children who are preparing for JEE Mains and Advanced. Clear? Relation and function chapter. I am going to focus on counting number of relations. Clear? Acha. First thing is that all of you know that what is relation. Okay, relation is coming from the Cartesian product. Clear? Relation is coming from the Cartesian product. What was Cartesian product? Try to recall what was Cartesian product. Cartesian product was not any type of product. In the Cartesian product, we were making pairs. Clear? We were choosing elements from two sets. We were choosing elements from two sets and we were making pairs. Clear? Let me give you the example. See here. First, I am going to discuss the Cartesian product in brief, then I will go in the counting relations and all those things. Clear? So, what was Cartesian product? Cartesian product, I am giving you a quick example, a quick recap. Suppose we have a non-void set A, okay, non-empty set A, and we have here elements A and B, small a and small b in this set, and another non-empty set B where we have 1 and 2, okay, where we have 1 and 2. Now, Cartesian product, what you have learned is that if you are doing A cross B, then I am going to make ordered pairs. What were ordered pairs? The rule was that only one rule was that in the pair I am going to write pair inside the first element. I am going to write first element here in this dot, first element, and in this here I am going to write second element, first element, second element. First element should be taken from set A and second element should be taken from set B. Clear? So here the Cartesian product will be A comma 1, then A comma 2, then B comma 1, and then we will get B comma 2. Clear? This was the Cartesian product. Now you see here what was the relation, what was the relations. Now when we are doing A cross B, these four pairs are possible, nothing more than that. Okay, these four pairs are only possible. Now what was the relation? Try to recall. In the relation we take some of the ordered pairs and we make the relation. There some rules are given to make the relation, and the basic thing was we take some amount of ordered pairs. We can take all ordered pairs also. That will be called universal relation. Try to recall. If I take all ordered pairs here, that will be called universal relation. Now, I may not take any of the pairs. I may not choose any of the ordered pairs. That will be empty relation. Okay, those are two extremes. Clear? So it is like take a practical situation. It is like a suppose four candidates came for giving the interview. Here, four candidates came for giving the interview. First candidate, this one A comma 1, second candidate A comma 2, third candidate B comma 1, and fourth candidate B comma 2. Now the company may select any one of them. Clear? Any one of them. May select any two of them, may select any three of them, may select all of them will go home happily, or may select none. That is the worst case scenario. So that is the way we make the relation. Now here what is happening, suppose I am writing a relation R. Clear? Now in this relation R I am taking only these two. Okay, my choice, I am taking only the first one and third one. So in this relation these two pairs I am writing, this is a relation having two elements. Okay, Now somebody can write another relation taking more elements. Clear? So this was the situation of Cartesian product. Now let me go for the counting of relations. Now how many types of relation can you recall? How many types of relations were there? The types of relation were identity relation, reflexive relation, symmetric relation, then transitive relation. These were the relations. Okay, universal relations. So specifically, I am going to count the number of relations possible, how many identity relations possible, how many reflexive relations possible, how many symmetric relations possible, like this. Now here I am going to make a twist. Here for counting those things, I am not going to take two sets, I am going to take only single set. Okay, let me show you what I am going to tell. I am going to take one single set. Just a second, let me erase it. Suppose I have only one set A, and in this set, 1, 2, 3, like this, n number of elements are there. Okay, say set of, say, natural number or whatever, the set A I have taken. Now here, if I make A cross A, what I will get? If I make A cross A, I will get here many ordered pairs. Okay, how many ordered pairs? Because for set A we have n elements, so n elements into n elements. Clear? So n square number of ordered pairs we will get. Now what I am doing means I will get this type of ordered pairs. Clear? 1 1 1 2, like this. The last one will be n comma n. I think you are getting me. Last one will be this. N square number of elements will be here. Clear? Okay. Now what I am doing for counting relation, first I want to count the identity relation. This is identity relation IA. Then I am going to count the reflexive relation. Clear? Reflexive relation. Then I am going to count the number of symmetric relation. These three things I am going to count, and I am going to give you the formula. Clear? So how we are getting this? You see, this is the first element. Okay, first element, these are the first element should be taken from set A, and second element also will be taken from set A. Clear? The relation on same set. So here, suppose I am doing 1, 2, 3, 4, like this. We have n number of elements written horizontally. Now again I am writing 1, 2, 3, 4, 5, like this up to n. So here I have written vertically. Clear? Now what is happening here? What is happening here? Here 1, 1, 1, 2. How these things are clear coming? So here, from here 1, from here 1, means the first pair is created 1, 1. Clear? Now if I am keeping this fixed, so here I am getting 1 comma 2. Sorry. After that 1 comma 3. Sorry. So this way we are getting, here in the first row the last element will be 1 comma n, like this we are making, and the below that sub you will get 2 comma 1, like this. Clear? So what I am focusing, you see, if you see the diagonal, clear, if you see the diagonal, so here I will get 2 comma 2, then you will get 3 comma 3, then you will get 4 comma 4, like this. Here at this corner, at the last, you will get n comma n, and that is the last ordered pair. Clear? In this Cartesian product. Now, so means if you focus on this diagonal, the elements are same. First element and second element are same. You can see these are the special elements are placed here in the diagonal. Clear? Now, what is identity relation? In the identity relation, the relation between same elements only. I am focusing on the word only. Relation between same elements only. 1, 1, 1 has relation with 1, 2 has relation with 2, 3 has relation with 2, 3, and n has relation with n. So these, if I take all these pairs, I will write nothing but the IA, means the identity relation. Okay. So in the identity relation on A, from set A to set A, these are my elements. Clear? Now all the elements should be taken, because I have told you relation between same elements only. All the elements should be taken, and if you take all these elements and make one set, you will get a single set. And how many elements will be there in that set? Okay, so in the IA, how many elements? How many elements will be there? You see, one, two, three, like this. Obviously, n number of elements will be there inside the set. But how many relations are possible? This way, only one relation possible, only one identity relation possible, and in that identity relation, all these pairs should be included. That's all. So here, if I want to count the number of identity relation in any set, only one identity relation we can make, and all these type of elements, all these pairs should be included. I think I am clear. Just a second. Okay. Now, so here again I am repeating, only one identity relation possible. Okay. Now you see what is happening. So identity relation, how many possible? Only one. Okay. Now let's focus on the reflexive. What is the definition of reflexive? In the definition of reflexive, it is told that relation between same elements. In the identity, I have told relation between same elements only. Only. In the reflexive, it is told relation between same elements. I am not saying the word only. It means what? It means relation between same elements. Okay, fine. Some extra also can be taken. Some extra can be also included. Because for making a reflexive relation, these elements must be taken. These identity elements must be taken. After that, you have to take some extra. You can take some extra. Now, from where you will get some extra? Some extras are here, this side. This side, obviously, just a second. This side you have extra in this triangle, and this side also you have extra. This, in this triangle you have extra pairs. In this triangle you have extra pairs which are not this type. Clear? Not this type means, if you see this side, if you see these sides, the in the pair, first element or second element are not equal, and this side also first element and second elements are not equal. Now let me count it. Count here. Total, I have told n square. Total is n square. This here is n, here is n. Total is how much? N square. Total is n square. Now these n elements are here. N elements are here. So this side and this side are symmetrical and equal. Clear? So this side will be n square minus n upon 2. These many elements will be in this triangle, and this also n square minus n by 2. These many elements will be also in this triangle. Clear? N square minus n by 2 elements here, n square minus n by 2 elements here, and n number of elements here. If you add all this thing, you will get n square. Clear? Now, in the reflexive, what we are doing, we have to take this element mandatory. All these elements should be taken. Okay, all these elements taken means that is one way. Only one way you can uh, recall the concepts of P and C, permutation combination. Only one way I can select them all. Clear? Now, so I am talking about reflexive. I have little space crunch here, so you can understand. So all these identity elements can be selected one way. Okay, one way. And here you see these elements, you can see. Now all these elements here, n square minus n by 2, here n square minus n by 2. So these elements, each of these elements I may select or may not select. Clear? Suppose in this triangle, these many elements are there. I may select or may not select. These many elements are there. I may select or may not select. So it means from here also I may select or may not select, or here also I may select or may not select. So what is happening here? Here I have two options, yes or no. Here also I have two options for each elements. Okay, yes or no. Two options for each elements. So total, if you see the total here, this one and this one, total is how much? If you add this one and this one, the total I am writing here, I am having some space crunch. You can see total is n square minus n. Okay, because 2 time if you multiply this by 2 you will get total triangle value is n square minus n, and each element of this n square minus n has two options, may be selected, may not be selected, may be selected, may not be selected. Okay, so what is happening for these elements, we have two options for each, so 2 to the power n square minus n. Clear? So number of reflexive relation, what I am getting here, 2 to the power n square minus n. So if I write it in a proper way, if I write it in a proper way, so here I will get 2 to the power n common n minus 1. These many reflexive relations are possible. Okay. These many reflexive relations are possible. Okay. Now I am going to show you the symmetric one. For that reason, again I have to make this diagram, and I have clearing, again I have to make this diagram. Just give me a second. Okay. So what I have got here, I have got what I have got here. I have got number of identity relation, that is 1, then number of reflexive relations, that is 2 raised to the power n into n minus 1. Okay, 2 raised to the power n into n minus 1. Now I am going to get number of symmetric. Again I am making that chart. Here those elements were there, 1 1, 2 2, 3 3. These elements were there up to n comma n. Okay, here n elements were there, total n square was there, this side n square minus n by 2 elements were there, this side also n square minus n by 2 elements were there. Clear? In this triangle these many elements were there, in this triangle these many elements were there. Now for symmetric, what is the thing? In the symmetric, what is the definition? Like if one suppose if you have relation between a and b, then you will have same relation between B and A. Clear? If you have relation between A and B, then you have same relation between B and A. Okay. Means if A and B is present there, B and A must be present there. Clear? Same relation. So I can take all this. I have advantage. I can take all this because you see one has relation with one, and if you turn this, means if you shuffle them, it is same only. 2 and 2, if you shuffle them, it will be same only. So these elements I can take. So here I have n options, means n elements are there. Okay. So here I have n options, means each one of them can be taken or may be taken, may not be taken, may be taken, may not be taken. Again, two options for each one of them. For these diagonal elements, we have two options. How many elements are there? N elements. So 2 to the power n. Okay. For these diagonal elements, we have 2 to the power n. Now what happens here, from here, suppose next element is 1 comma 2 and downside the next element is 2 comma 1. You see, next element here 1 comma 2, downside you have 2 comma 1. So if you are selecting this, you have to select this to keep it symmetric. Means if this pair is selected, automatically you have to select this pair. So it means if I take these elements, automatically I am taking these elements. So I will not consider both of them. I will consider only one of them, because if I am selecting any one pair from here, automatically the counterpart will be selected. So it means here what is happening, let me write it clearly. Just a second. Number of these relations, number of reflexive relation for the diagonal elements, 2 to the power n. And here also this has two option again. So if this has two option, then again 2 raised to the power n square minus n by 2. This is happening for the number of reflexive relation. Clear? So this is happening for the, sorry, number of symmetric relations. Okay, I am doing for this, doing for symmetric relation. Okay, symmetric relation, reflexive already I have written here. Number of symmetric relation is coming to be this. Now if I simplify this, both are the power of 2. You see, both are the power of 2. I will add both the power. If I add both the power, the LCM will be 2. Okay, and here it will be 2n plus n square minus n. This I will get. Okay, this I will get as number of symmetric relation. And if I simplify it, it is n square plus 2n. Sorry, here what I am getting, n square plus n by 2. This I am getting. Clear? 2 raised to the power n square plus n upon 2. So if I take it common, if I take n common, then n plus 1 by 2, this is coming. Okay, it is a sum of natural number thing. Okay, n into n plus 1 by 2. So this is the number of symmetric relation. Now I will sum up all the thing what I have got. Let me erase it and then I am going to sum it up. So what I have got here, I have got here number of identity relation, number of identity relation, number of identity relation is one, only one. In that relation, all those diagonal elements will be taken. Okay, then number of reflexive relation, number of reflexive relation, what I have got, 2 raised to the power n into n minus 1. Clear? And then what I have got, number of symmetric relations, that is 2 raised to the power n into n plus 1 upon 2. So these are the thing coming. Okay, so I have made the proof that how these things are coming. These are very useful while calculating the counting the number of relations. Okay, okay, bye.